Okay.
So did you guys bring questions? Hi, Kristen.
Hi.
Y'all bring questions for me?
Did I?
Yeah.
I just kind of showed up to show up.
It's a typical review session when everybody just sits there and says, Mr. Roboto, teach me everything you know. Yeah. I wish I could like take my brain and put it into yours tomorrow. But I can't unless you ask me questions. So ask me questions. And I'm glad that I'm going to show you some stuff that you should know, definitely. How many of you did the workbook today?
I am currently doing it.
Sweet. How'd you do, Aiden?
I did pretty good. I just have to, I'm gonna save set 1 for tonight to study.
It's a good idea. Yeah. Good.
So
I see
Mr.
some thumbs up there. That's good.
So Mr. Roboto, if the students did the workbook, studied that in the reference tables very well, should they do pretty well in this
They should.
test tomorrow?
Yeah, that's what, who asked me that today? Somebody sent me an email. Yeah, that section for some odd reason, like kind of covers everything. That's why I waited to do that one for last. It covers pretty much every topic that we've done in meteorology from the very beginning through now. So just recall that like this book is probably, if you want to study something, like this is the go-to right here as far as, you know, studying. You have all the section 1 stuff that the set 1 things that you haven't probably done yet. And so there's some good review there. And if you want to know what pages to start on, I'm looking right now, hold on.
163.
Even before that, but like there's questions on dew point and humidity that start on page like 139. And that goes all the way through relative humidity to page 149, starts on temperature. Air pressure starts on 153. It just keeps going. You guys didn't do any questions related to air pressure yet. So like 155, 156. I just posted that online today. If you want to check out 155 and 156. I didn't put the answers up there, but those are good questions too on air pressure in there. So that's big. The test tomorrow, just to give you guys a little bit of a format idea, I just finished it this morning. It's 21 questions total. Okay, so it's not super long, 21 questions. I'm giving you half an hour to do that. Okay, so it's a 30-minute test tomorrow. And 21 questions in 30 minutes should be no problem because most of them are multiple choice. So I think of those 21, like 17 or 18 of them are multiple choice. I forget exactly the number. So just a heads up there as far as your format for this thing tomorrow. The questions will be scrambled, of course. So it'll be random, like when you go from one question to the next, it'll be pretty random. I made sure that all the pictures look okay. Remember, don't click on the pictures because that always bumps you out. Some of the pictures are a little bit bigger than I wanted them to be, but you know, it's fine. You can see everything. So that's kind of the format of the test for tomorrow. So it covers everything from pages 12 through 14 in your reference table. Okay, so that would, I'm going to share my screen with you all. Let's see, here we go. Okay, so yeah, so starting with being able to like use this chart and this chart, dew point and humidity, and making sure that you know how to like use them with each other. So like, for example, if I say the temperature was 18 and the dew point was 15, what's the relative humidity? You got to be able to do that on this chart. So how do you do that? Well, here's 18. Okay, that's the temperature. Here's the dew point right here of 15, which means there's a difference if you look up of 2. Okay, so you start at 18, the difference is 2. And then you go down to this chart and say, okay, 18, and 2, what's the relative humidity? It's 81%. Okay, so using those two charts together, I know there's definitely a question like that tomorrow. That's one of the trickier kind of questions that you might get using these charts here. Okay, are there any questions about page 12 that you want to ask me? You can speak up if you want. Nothing? Sweet, everybody's gonna be super quiet because they don't want to participate. I should do forced participation. That'd be great. No, I won't do that. Okay. Page 13 of your reference table, there is not a single question using the temperature scale, but you know, it's there, okay, for reference sake. I mentioned the air pressure chart here. There's no questions where you gotta like say, okay, if you have a pressure of 1016 and what is that in inches of mercury? You're not gonna have to do that, but just be aware that this chart helps you with station models. And I've said that a couple times now, like if you decode a station model and you get a number that's not on this chart, you did it wrong. Okay, that's like your way of checking your work. Okay, and what do I mean by that? Like this pressure right here in the station model is 196. To decode that, you add the 10 to the front of it because it's less than 500 and you get 1019.6. Okay, if you wrote 919.6, then it's not on this chart and it doesn't work. So just to be aware of that, it's a really good way to check your work there. Okay, a lot of questions on station models. I think like 4 or 5 questions on station models. Okay, so being able to use that chart. Obviously, you're not going to have to draw a station model because that would not work. If this was a real classroom situation, I would totally make you do one. And actually, we were going to do a lab with station models. I had to skip it entirely. So you're not drawing anything, you're just interpreting them all. This is there to help you. Notice the station model is here, but the explanation is here. Okay. One really big thing with station models that kids always mess up on: wind direction. Wind direction is always named after where it comes from. Okay, so this wind that is shown on this diagram here is a southwest wind. It's coming from the southwest. You would say the wind direction is southwest. Okay, now notice the line is kind of pointing to the southwest. So if I were to say draw a northeast wind, then you have to draw a line to the northeast. Okay, that's really key, is being able to draw your wind direction and wind speed correctly. Long lines are 10 knots, short lines are 5 knots. Okay. Are there any questions about wind direction or wind speed on a station model?
Yes.
Go ahead, Aiden.
So for the wind speed feathers, does it matter which way those are pointing?
No.
Or no?
No, it doesn't.
Okay, that was my main thing.
Yeah. No, that's cool. Either side is fine. You don't even have to angle, they angle them a little bit. You don't have to do that.
Okay.
And you're not going to draw anything anyway, so it doesn't really matter. So, but yeah, it wouldn't matter. Okay. I know there's a question about, you know, wind speed and wind direction and interpreting that. So that's why I just put that on to you. Okay. Somebody's got their sound on. I don't know who that is. All right. Other questions related to this, decoding pressure. I gave you the rules yesterday, right? And guys, feel free to write the rules on your reference table. I'm letting you do that. Right? If this number is less than 500, then you would put a 10 in front. And if it's more than 500, you put a 9 in front and then put the decimal in between the last two. This number here, that's the barometric trend. You're gonna have to put the decimal in between these two numbers. Okay, that's key too. Like this is not a barometric trend of 19 millibars, it's 1.9 millibars. So make sure you know that. Okay, that's kind of a key thing. Air mass questions. You guys have to know what maritime means, where maritime would be located, and where continental would be located. And obviously polar and tropical, you gotta know that too. Maritime's over water, continental over land. Okay. These present weather symbols are going to be used, I think, once or twice. Fronts, there's going to be a question like, what kind of front is this? All right. Oh, hold on, I got to do one other thing. Hold on. Can I do this way? Stop sharing. Hold on. I'm going to share a whiteboard. Where's the whiteboard? There it is. Okay. Guys, cold front. You guys got to know what a cold front looks like. All right, here's a cold front. All right, here's that front of that cold air. This is cold air. We would probably call that polar, right? Capital P for polar. Maybe it's continental polar coming in from Canada or something, okay? This warm tropical air, let's call it maritime tropical. I'm just making this up, okay? Tropical air is warm. When it runs into that tropical air, that warm air, it rises like that, which is going to form all those clouds right here. It's always raining right on the front line. Okay, so here's the rain coming out of that. This is a terrible drawing. You guys get the idea. Okay. So definitely know what a cold front looks like. A warm front looks like this. Okay, here's the warm air right here. Warm. Wow, it's hard to write with a mouse. And cold over here. Okay. And the warm air kind of rises up, pushes the cold air really slowly. Cold air is really fast moving, pushes the storms up really quickly. Okay, so know the difference between a cold front and a warm front, like what they look like on the side. Those are the only ones I would ever ask about. I wouldn't ask about occluded fronts or stationary fronts. What else? What else? Go back to my reference table. Okay, I think that kind of covers this part of it. Definitely a question or two about the layers of the atmosphere, like you know, what layer is like where there's the most water vapor, okay, or something like that, or what happens to pressure when you go up in altitude, kind of like a graph question. This is a graph right here, guys. This is altitude, right? Altitude going up, pressure going this way, and you can see like an inverse relationship. It kind of goes down as you go up in altitude, or it goes up as you go down in altitude. They're always opposites of each other. Okay, so that's kind of a, you know, a classic question. Like the bottom layer is the troposphere, where all the water is located, cloud formations down there. Stratosphere is where the ozone's located. Okay, so, you know, just basic stuff related to that diagram there. Any questions about this diagram? Layers of the atmosphere? Nothing too tricky. No? Sweet. Okay.
How about the greenhouse effect?
What's that?
Any questions regarding the greenhouse effect?
Yeah, I was going to get to that with this actually. Yeah, there's one question on the greenhouse effect, and I'll tell you basic. I'm going to give it away, but that's I'll explain what I want by it. Okay, so this chart right here, if you you got to know about like the different zones along the Earth's surface. So this wet zone here is where there's low pressure, it's rainy. Look at the lines, the arrows are coming together and converging, right? The southeast winds and the northeast winds are converging here. That's what's going to make low pressure. That low pressure air is going to rise, okay? And rising air is going to form clouds and condensation and cooling off and precipitation, all that stuff, okay? Dry zones are up at 30 north and 30 south. Why? Because the air is diverging, right? Diverging away from that 30 north line. So that's really big too. High pressure, the air is sinking back down again. It's pretty cold air. Or, sorry, yeah, it warms up as it sinks. But yeah, so definitely know about these pressure zones. Okay. Any questions about planetary winds anywhere? No, we're good. Sweet. Okay. Electromagnetic spectrum. Mr. Person kind of touched on it with the greenhouse effect. So yesterday, was it yesterday that we watched that video on greenhouse effect?
Yes.
Yeah, I did. It's so weird because when I teach, this is weird. I am preparing the lesson the day before. And so what's in my head is always like the day before, and what you're actually doing is like the day after I do it. So I'm like all messed up in my head. I don't know what day it is. Is it Thursday? It is. Okay. All right, sweet. It's this whole thing is messing me all up as far as the calendar is concerned. So anyway, when light when energy from the sun reaches Earth's surface, it mostly comes in the visible light spectrum, okay? And that visible light spectrum, you know, you get the whole entire wavelength of everything. Now, once it bounces back off of Earth and reflects back off of Earth, the Earth absorbs a lot of energy and it warms up. And that heat energy is infrared energy. Infrared energy is given off by the Earth, okay? And he kind of talked about that in the video. Infrared energy that comes off of the Earth, let me do this, hold on. I'm getting good at this whole Zoom thing. Okay. How do I erase my board? I'm not. I don't want to do that. Clear it. Clear all drawing. Okay. Yeah. That. There we go. Okay. So let's say here's Earth's surface, and we have energy from the sun reaching the Earth's surface. Right. There's electromagnetic energy, mostly in the visible light spectrum. Here's the atmosphere right here. That was terrible, but you get the idea. Okay. Infrared energy is longer wavelength, and it gets stuck in our atmosphere because we have these things called greenhouse gases. Carbon dioxide, methane, water vapor. You get the idea. These gases kind of trap some of that energy. They're like the blanket inside of this area. Okay, so you have visible light coming in, infrared bouncing back out, but it gets trapped in here. Okay, now if we had no atmosphere, all that infrared would just go out into outer space and the Earth would be like an ice block, like Pluto, okay, or the moon even. So we're thankful that we have a greenhouse effect of these gases. We wouldn't survive without this trapping heat, right? Now there's what we call natural greenhouse effect, and then there's what we call anthropogenic greenhouse effect, which is more like the humans are contributing to these gases in the atmosphere. That's bad and all that stuff, okay? But know that idea, okay? I'm not gonna ask you a question like, name one greenhouse gas. That's too easy, okay? But I will ask you about this idea of trapping heat in the atmosphere due to the like infrared is bouncing out. There was, and I'm gonna give it away here, okay? See this book right here? The question that I'm talking about, all you people that tuned in and are gonna watch this video later on, it's on page 187, okay? That's the question. I'm not gonna tell you which question it is, but it's on page 187, okay, in your workbook. Heads up there. I basically just drew it, okay? All right. Sweet. So I went through all the reference table page. Oh. Haha, I just thought of one. Hold on, go back here. Clear drawing, clear. There we go. All right, back to drawing here. You guys remember the whole sea breeze come get your summer thing? Did you like that? Did you see that in the video? Yeah, I put it in there. I inserted the little clip from sea breeze. All right, anyway, here's the ocean. All right, ocean is spelled O-C-E-A-N. Okay, here's the land over here. And what happens to the land during the day? Let's say this daytime. What happens to the land? There's my awesome son. Come on, this is a participation. Say it. What happens to the land? Unmute yourself and say something. Not you, Mr. Person. Come on, kids. What happens to the land? What?
It warms up during the day.
Very good. It warms up during the day. More so than the ocean. Why? Because the ocean is made out of water, right? And water takes a really long time to warm up. It has a high specific heat. So that the air above the land heats up and it rises, right? Okay? And this is what happens, it becomes low pressure, okay? The air sinks, it moves over here, and then it sinks over the ocean. The ocean's cold, okay? And then it comes in like this. That's during the day. Is high pressure over here, sinking air, low pressure rising air. You gotta know that, okay? That's a sea breeze, come get your summer. Sea breeze is during the day. Okay, why is it called a sea breeze? Why is it called a sea breeze? Because it's coming from the sea. Okay, remember you always name the wind after where it comes from, coming from the ocean. All right, guaranteed gonna be a question on there, okay, about sea breeze. Or land breeze. Land breeze at night. It's the opposite, right? It blows from the land over. Okay. Questions about that? Anything? Okay. I'll leave it open for you. Oh, where was it? Where was it? Yeah. Hold on. I have, this thing always gets in my way. A little pop down screen in the screen share always gets in my way. Yeah. Okay. So guys, see all these workbook pages that you've done already? These are all related to meteorology. They're all in the Earth Science folder, homework worksheets, Unit 7. You've done them all. You've done questions based on them. I'm asking you questions. Some of them are coming directly from here. Okay. I added this one today. This is page 155 and 156. There's a good question about sea breeze, land breeze. Somehow the, that has high pressure and low pressure, doesn't have arrows. That's kind of a tricky one. Okay. This is a great question about, sea breeze. We got pressure over the land of 1013, no pressure over the ocean. We got to figure out what the pressure over the ocean is. If it's moving from the ocean to the land, it's going from high to low pressure. This number out here has to be bigger. Okay. Remember, high to low pressure. Oh, another thing related to wind. Remember where the lines are really close together? It's windy. That's on there. Okay. Questions? Anything? Aiden?
I have a question about the lab, if
Oh,
you
yeah.
have time afterwards.
No, we can answer it now. Everybody's probably going to benefit from it. So,
Okay, so it's basically about like the last 4 questions that are based on New York State.
Yeah.
And it talks about like climate control factors. That's just the factors on the top part, correct?
Yeah.
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 Okay. That's what I think.
Yeah, so hold on, let me share that. I have that somewhere. That's under labs, Unit
I
7.
don't know. I was just kind of struggling with these for some reason.
The last 4.
Yeah.
All right. So question, these actually, I took these from a Regents exam. Average monthly temperatures for zones 1, 2, 3, and 4 are similar to each other. So why would they be similar to each other? Well, notice they're all in New York State, right?
Mm-hmm.
And that's kind of key. Think about something that's true about, in general, about New York State. They overall have pretty similar temperatures because they're all at a very similar latitude, right?
Yeah.
There's not a big difference, if relatively speaking, across the whole entire planet. If we were talking about the whole planet, there's big temperature differences, but in New York State, there's not a huge difference. It's mostly based on the latitude's the same. Okay.
I might throw in one tip for all the students on that lab. Regarding New York State, you want to check in page 2 of your reference table showing New York State and its geology, which is all about elevation.
Yep, there's some elevation differences, definitely, like in the Adirondack Mountains, which is zone 3 over here. There's an elevation difference. Okay. And that's kind of related to some of these things too. Okay, at least number 3. Any other things about that, Aiden?
No, that's pretty much it.
Okay.
For that.
All right. Hopefully these ones up here were not too terrible.
They're pretty easy.
There's a question related to this diagram idea. Okay. This imaginary continent question. There's one question on that on the test tomorrow. And actually, I think it is one of these questions. I'm not going to tell you which one it is, but related to that stuff, related to these factors here that affect climate. It's a really good chart. Guys, this would be if I were like giving an open binder test kind of thing, this would be something I would have printed out for you and given to you, because this is really helpful, really important information. It kind of summarizes all the climate stuff and to have. Okay. All right. Anything else? We'll shut it down. We've gone about half an hour or so.
And was this recorded for those that may have missed this?
Yeah. Yep.
Okay.
It was. So, yep, I'll put it on YouTube later today. Okay. And I'll post the link right on the agenda, and I'll put it on YouTube. I don't make Zoom calls publicly available. I'd rather not post that for everybody in the world to see. So, just for the sake of not having your face out there everywhere on YouTube. Okay. If you are like Aiden or Caitlin that have your face visible, nobody else has their face visible. So. And me and Mr. Person, we don't really care, but my face has been visible for the last 2 months on the internet. So, anyway, so yeah, this will be online, and I'll post the link on the agenda, and you can check it out later if you want. And if you didn't watch some of the review from the workbook today, definitely do so, because I went through every question in detail, and I took my time going through that, so because it really does cover a lot of the meteorology stuff that's on there tomorrow. Okay. Questions for me? Anything else? Last minute? No? How are we all doing? Mentally? Emotionally? Yeah. Hanging in there? You're all not going to share in front of each other, obviously. I didn't expect you to, but thumbs up from Ryan. All right. Oh, look at all the thumbs up.
Yeah, thumbs up, Sean.
Thumbs up. Thumbs up. Me too.
Good. Kayla, Claire, Georgia.
Yep. Yep. Good. It's okay. So last time we had a Zoom session, I think Jane asked me whether it was going to warm up anytime soon, and I'll tell you that it is. Okay. My weather prediction is that it's going to stay warm from pretty much now on. Okay. So if you want to have like happy thoughts, there's my happy thought for the day, that it's going to be 85 next week. So it's gonna warm up. Okay. I'm not saying it's going to warm up like to the 80s for the rest of the time, but it's going to stay warmer, I think. I don't think we're going to have any more snow. Okay. So, yay. That's exciting. So, anyway, that's it. Guys, if you have any other questions today, you come across or whatever, send me an email. Okay. And I will be glad to answer them. And hope you all are doing okay. All right. Cool. Cool. All right.
Thank you.
You're welcome. Good to see you all. Well, sort of. Good to see your names. Have a great day, guys. Bye, Mr. Person.
Goodbye. Thanks, Mr. Roboto.
You're welcome.
See you, Caitlin.